Today we're looking at lesson 15.1, which is about a two-way frequency table. Now, a two-way table is a way of looking at two different variables, and we're looking at tables in a horizontal method and also in a vertical method. We're finding different ways to compare two variables. From this example, you can see that the top of the table is comparing people that shop at a farmer's market versus people that don't shop at a farmer's market. And we're comparing that with people that own a bike and people that don't own a bike. Now, I don't know about you, but I've been to a lot of farmers markets to buy fruits and vegetables, and I've seen a lot of people that ride their bikes there. So a poll of 120 residents finds that 40% of them own a bike. So you might want to open up your calculator. We're going to do a little bit of work here. And the first thing we want to do is find out how many people actually own a bike. And the way you find that out is we take the number of people, which is 120. That's that number. And it says 40% of them own a bike. So we're going to multiply that by the decimal form of 40%. You'll use your calculator and find that that leaves us with 48 people actually own a bike. And so I'm looking in this bike column or versus no bike. Well, 48 people are the total number of people that own a bike. And I already know that the town residents that were asked, there's a total of 120 of them. And this bottom right-hand corner is always for the total of whatever is asked. So the next part of it we need to answer is this second sentence says, of those who own a bike, remember that the people that own a bike is 48 people. So 48 people have a bike. 75% of them shop at a farmer's market. So 75% of this number, which we're going to multiply by 0.75. And if you use your calculator, you're going to find out that this gives us 36 people that own a bike shop at a farmer's market. So if you own a bike and shop at a farmer's market, you're one of those 36 people. Now here's how a two-way table works. The horizontal rows all add up to this total. So if this is 36 and the total is 48, then the missing number is 12. And so I'm going to go ahead and fill that part in. This missing number here is 12. And if this is 48 people that own a bike and there were 120 people total asked, then out of the 120, if only 48 owned a bike, if I subtract those two, we're going to find out how many people actually don't own a bike, and that number comes out to be 72 people that don't own a bike. Now we have to look at one last part of this problem, which is this last sentence here that says, of those who do not own a bike. So when they say not owning a bike, we're talking about students in that box right there. 72 kids don't own a bike. It says, of those who do not own a bike, 25% of them shop at a farmer's market. And if we take that 72 students that don't own a bike and we multiply it by 25%, which is 0.25, 25% of 72, if you use your calculator, comes out to 18 students. And so let's go put that 18 in the right box. It says, of those who don't own a bike, so I'm in this row here, only 25% of those shop at a farmer's market. So 25% of this number shop at a farmer's market, so the 18 is going to go right there. Now I cleaned up the workspace and just left the table filled in so we can address this question, which asks, does the table show a correlation between people who own a bike and who shop and people who shop at a farmer's market? So to answer that question, we have to do two things. We have to find out what's the chance that any one of these 120 people will actually go to a farmer's market. And the numbers we're going to compare are the total number of people compared to, out of all the people, how many people actually go to a farmer's market. And so 54 people total go to a farmer's market, and 120 people were asked. And if we come over to the Desmos calculator and we take 54 and we divide that by 120, that's going to tell us what's the relative chance or the relative frequency. And it comes out to be 0.45. So 0.45 as a percent is 45%. So the chances of you being a town resident and going to the farmer's market, there's a 45% chance that you're a town resident and go to a farmer's market. But when we narrow that scope and we want to look at what about just the bike owners? What percentage of them go to a farmer's market? Well, there were a total of 48 bike owners, so we're no longer comparing to 120. Now we're just comparing to the 48. And out of those 48, how many people actually went to the farmer's market? Take a look at the table and see if you can pick out the number of bike owners that went to a farmer's market. It's that number right there. It's 36. And if we take 36 and divide it by 48, so I'll take 36, divide it by 48, and you'll see the relative chance, 0.75. 0.75, which is 75%. And so to answer the question, we have to ask, is this number significantly different than this number? And the answer is, it's a judgment call, kind of make an observation that 75% really is a lot more than 45%. So what this suggests is, yes, if you're a bike owner, you are much more likely to go to the farmer's market than if you're just a randomly selected person in the town. So here we go again with another problem. In a survey of 50 students, once I know that 50 students were surveyed, that's my total that's the total, the whole table, everything adds up. It's got to represent 50 kids were asked this question. Out of the survey of 50 students, 60% said that they have a cat. 60% of 50 students, meaning we've got to multiply 50 times the decimal of 60%, which is 0.6 or 0.60, and you can use your calculator if you wish. That comes out to 30 people. And so in a survey of 50 students, 60% of them or 30 of them said they have a cat. So 30 out of the 50 have a cat. Well, I know that this column is going to add up to 50, which means this number right here has to be 20, because 30 plus 20 is 50. Now let's read the second sentence. Of the students who have a cat, that's this number right here, that's 30. 70% of these also have a dog. So 30 times 0.70, 7 times 3 is 21, and when I move the decimal a couple times, if you use your calculator, it'll come out to that. 70% of cat owners also have a dog. Well, 21 students out of these 30 also have a dog. Now let's read the last part of the problem. Of the students who do not have a cat, that's this problem, that's this number right here, 20. 75% of these students do have a dog. So 75% of 20 are going to go in this box right here. So people that don't have a cat, 20 students don't have a cat. 75% of them do, though, have a dog. And if you multiply that out, you're going to get 15. So out of these 20 non-cat owners, 15 of them have a dog. And once I have this, I'm going to be able to add the rest of these up. For example, I know this is a total. 21 plus 15 makes 36. So right now I know 36 total kids out of 50 had a dog. 21 plus this number is 30. This number has to be 9. And 15 plus this number has to be 20. So that has to be 5. And now that I can add this column up this way, 9 plus 5 makes 14. So out of the 50 kids we asked, 14 of them don't own a dog and 36 do. Let's address this correlation question again. We're asked to find out if there's a correlation between people who own a dog and people who own a cat. Meaning, are you more or less likely to own a cat if you also own a dog? So let's take a look at, just answer this question. What's the percentage of people, or what's the frequency that we might run across somebody who owns a cat? And the total number of cat owners, just a cat, is 30 out of a total of 50 people. So people that just own a cat, that fraction is 30 over 50. And if you divide that in a calculator, 30 divided by 50 is 0.6, which is 60%. So 60% of the people that were asked own a cat. So the last part of the question is we need to answer what percentage of our cat owners also own a dog. And so if we want to look at a correlation between owning a dog and owning a cat, well, 21 of the total students asked own both. 21 students own a dog and a cat. So we want to know, is there a relationship between owning a cat and also owning both? So out of owning a cat and owning a dog, that's 21 of our cat owners own a dog out of the 30 cat owners that we asked. So 21 over 30. And if you divide that in a calculator, you will get a nice round 0.7. So the chance of us just running across somebody and having them own a cat is 60%. The chance of us finding cat owners that also own a dog is 70%. So we might make the argument that a cat owner is slightly more likely to also own a dog. And a lot of these are judgment calls. They're kind of observations. Statistics aren't usually cut and dry. Sometimes there's room for interpretation, and it's definitely room to make an argument that if you're a cat owner, you're a little bit more likely to own a dog. Okay, we're taking a look at one last example that is included at the end of your lesson. And we're just going to construct a two-way table from scratch using this example. There are no percentages, no multiplying. We're just going to take a look at a couple principles of two-way tables, and that is if you add up the numbers in a column, they should add up to a total, and each column should add up to its own total. And in addition, each row across will add up to a total. So let's take a look. Felipe surveyed students at his school. He found 78 students own a cell phone. Well, let's take a look. Cell phone. These are total students that own a cell phone. He found 78 total students own a cell phone. So we'll include 78 students there. And it says 57 of those students also own an MP3 player. Well, he chose the 78 students that had a cell phone, and he found out that 57 of them own an MP3 player. So right away, without having to read the rest of the problem, I know I can find this number because 57 plus this number has to add up to 78. So 78 take away 57 is 21. So that means if 57 had an MP3 player, 21 of them did not. Let's take a look. There are 13 students that do not own a cell phone. So 13 goes here somewhere. They don't have a cell phone, but they own an MP3 player. Well, that goes right here because these students have an MP3 player but no cell phone, and he found 13 students fit that category. And then it says 9 students do not own either one. So no MP3 player, no cell phone, that goes here, 9 students. And I know that I can add these up, and I'm going to get this total. 21 plus 9 is 30, and 57 plus 13 is 70. And that tells me right away that I know that if I add this way, 70 and 30, I get 100 total students. And if 78 of them had a cell phone, that means these two numbers here have to add up to the other 22 that don't have a cell phone. And that's how you construct a two-way table.